Lecture 1, Foundations of Chemistry and Scientific Thinking. Objectives. By the end of this lecture, you should be able to 1. Understand the importance of learning chemistry. 2. Define chemistry. 3. Understand scientific thinking. 4. Describe the method scientists use to study nature. 5. Develop successful strategies for learning chemistry. Introduction. Chemistry is often called the central science because it connects physics, biology, medicine, engineering, and even art. Every time you cook a meal, breathe air, or charge your phone, chemistry is at work. Learning chemistry is not just about memorizing formulas, it's about learning how to think critically, solve problems, and understand the world at both the microscopic and macroscopic levels. Section 1. The importance of learning chemistry. Chemistry explains everyday phenomena. 1. Why bread rises, yeast fermentation. Yeast ferments sugars in dough, releasing carbon dioxide and alcohol that make bread rise. The carbon dioxide forms tiny bubbles that become trapped in the dough by the gluten network formed from flour and water, causing the dough to expand and increase in volume. When the dough is baked, the heat causes these gas bubbles to develop further, strengthening the dough's structure, while the alcohol evaporates and the yeast dies, leaving behind a light, soft, and airy bread. 2. Why ice floats, molecular arrangement. Ice floats on water because it is less dense than liquid water. When water freezes, its molecules arrange themselves into a rigid, open lattice structure held together by hydrogen bonds. This arrangement spreads the molecules farther apart than they are in liquid water, increasing the volume without increasing the mass. As a result, the density of ice, about 917 kilograms per cubic meter, is lower than that of liquid water, about 1,000 kilograms per cubic meter. According to Archimedes' principle, a substance less dense than the liquid it is placed in will float, so ice remains on the surface. This unusual property of water is vital for life on Earth, since floating ice insulates lakes and oceans, preventing them from freezing solid and protecting aquatic ecosystems. How medicines work in the body. Medicines act in the body by interacting with specific biological targets, such as receptors, enzymes, or microorganisms, to correct or modify the body's function. Once absorbed, a drug is transported through the bloodstream to the site of action, where it may block harmful processes, replace missing substances, kill pathogens, or reduce symptoms like pain or inflammation. The body then metabolizes the medicine, mainly in the liver, and eliminates it through the kidneys or other routes. At the same time, the desired therapeutic effect occurs when the drug reaches an effective concentration without causing significant side effects. Chemistry empowers informed decisions about health, environment, and technology. Tricky question: if chemistry is everywhere, why do so many people believe they never use it? Although chemistry is involved in everything from breathing and cooking to cleaning and using medicines, many people believe they never use it because chemistry often works invisibly and automatically in everyday life. People associate chemistry only with complex formulas, laboratories, or school exams, not with familiar activities like food digestion, soap removing grease, or fuel burning. As a result, when chemical processes feel ordinary and require no conscious calculation, they are overlooked, even though chemistry is constantly shaping daily experiences. Section 2. Defining chemistry. Definition: chemistry is the study of matter, its composition, properties, and the changes it undergoes. Matter: anything that has mass and occupies space. Example: water, H2O, is matter. Chemistry explains why it can exist as a solid, a liquid, or a gas. Tricky question: is light matter? Why or why not? Light isn't considered matter because it doesn't have mass or take up space, as matter does. Instead, light is a form of energy that travels as electromagnetic radiation made up of photons. While photons can carry energy and momentum and interact with matter, for example, by heating objects or knocking electrons loose, they are not composed of atoms or particles with mass, a defining property of matter. Section 3. Understanding scientific thinking. Scientific thinking involves curiosity, skepticism, and logical reasoning. It means asking questions, collecting evidence, testing explanations, and revising ideas. Example: alchemists once believed lead could be turned into gold. Modern chemistry shows why atomic structure makes this impossible under normal conditions. Tricky question: if science is constantly changing, can we ever be sure about anything? Yes, we can be confident in scientific knowledge, even though science changes, because scientific ideas are refined, not discarded, based on evidence. Science builds explanations from repeated observations, experiments, and independent verification, so well-supported ideas, like gravity, atomic theory, or the conservation of energy, become highly reliable. When discoveries appear, they usually improve or expand existing models rather than prove everything was wrong, meaning science gives us the best possible understanding at the time, with increasing certainty as evidence accumulates. Section 4: The Scientific Method. Steps scientists use to study nature. 1. Observation: notice phenomena, plants grow toward light. 2. Hypothesis: propose an explanation, plants need light for energy. 3. Experimentation: test under controlled conditions. 4. Analysis: compare results. 5. Conclusion: accept, reject, or refine the hypothesis. Example: Antoine Lavoisier's experiments on combustion disproved the phlogiston theory and led to the discovery of oxygen's role. Tricky question: if an experiment fails, does that mean the hypothesis was wrong or the experiment was flawed? A failed experiment does not automatically mean the hypothesis was wrong, because the failure could also come from flaws in the experiment itself. Errors in design, measurement, controls, materials, or procedures can prevent the hypothesis from being accurately tested. In science, researchers first evaluate whether the experiment was carried out correctly and whether the data are reliable before rejecting a hypothesis. Only when well-designed experiments are repeated and consistently produce results that contradict the hypothesis do scientists conclude that the hypothesis is likely incorrect. Section 5: Strategies for learning chemistry successfully. Practice problems regularly to reinforce concepts. Connect chemistry to daily life: acids in lemon juice, bases in baking soda. Break topics into smaller steps: atoms, molecules, reactions. Collaborate with peers: teaching others strengthens your own understanding. Use visual aids like diagrams, flashcards, and concept maps. Tricky question: is memorization enough to succeed in chemistry, or do we need something more? Memorization alone is not enough to succeed in chemistry, because chemistry is about understanding how and why matter behaves, not just recalling facts or formulas. While memorization helps with vocabulary, symbols, and basic rules, real success comes from developing problem-solving skills, logical reasoning, and the ability to apply concepts to new situations. Chemistry requires connecting ideas, interpreting data, and thinking critically about reactions and processes, which goes beyond memorizing information. A clear example is the gas laws. A student can memorize Boyle's law: the product of pressure times volume is constant, but memorization alone does not guarantee success. If the student does not understand that pressure increases when volume decreases because gas particles collide more often with the container walls, they may not know when or how to apply the equation. When a problem involves a real-life situation, such as a bicycle pump or a syringe, only a student who understands the concept, not just the formula, can reason through it and solve it correctly. So, chemistry is not just a subject, it's a lens through which we understand the world. By thinking scientifically, applying the scientific method, and practicing effective learning strategies, you can transform chemistry from abstract formulas into a powerful tool for everyday life. Here you have a type of question in this class. True or false: chemistry is concerned only with substances produced in laboratories, not with natural processes. Answer: false. What is incorrect? Chemistry studies all matter and its changes, including natural processes like respiration, digestion, and photosynthesis. True or false: in the scientific method, once a hypothesis is supported by one experiment, it becomes a scientific law. Answer: false. What is incorrect? A hypothesis requires repeated testing and verification. Laws describe patterns, while theories explain them.